Hello, ladies and gentlemen. Welcome to another edition of Conic's Corner with your host, Kelvin Conic. Yes, my first name is Kelvin, and yes, it is a degrees of temperature in chemistry, and how you get to Kelvin is you take your Celsius degree and add 273.15 in order to get your degrees in Kelvin. That's a little chemistry humor to start off this presentation. Today we will be talking about a specific type of conic, which is the ellipse. But before we get into the actual presentation, I would just like to take a moment to talk about my 2-year academic goals, as well as future plans in academia. By the end of spring 2018 semester, I hope to have all my prerequisites done for pharmacy. I want to go to school to become a pharmacist, and hopefully by then I will have the prerequisites done so I can apply and start fall semester 2018. So with knowing my 2-year academic goal and plan, let's move on to the presentation. You first would be asking yourself, what is an ellipse? Basically, an ellipse is a collection of all points in the plane. The sum of those distances form two fixed points called foci. And the foci is always a constant. Basically what that is saying is the focus is a fixed point from which the distance to any other point of a given curve, especially this presentation on the ellipse, is connected by a linear relation. So the basic concept for the ellipse, we learned about what foci are in the previous slide. So if we take the distance from one foci to the other foci, represented here by these red dots, we will get the same distance. And that is basic concept for the ellipse. Now we're going to move on to properties of the ellipse. I know there's a lot of information on this slide, so bear with me here. We have two separate presentations for the ellipse. We have the horizontal ellipse, which if you look here, the major axis is here in green on the x-axis. The vertical ellipse, which is down here, second one shown, your major axis in green is your y-axis. They have two separate equations for each ellipse. The equation for your horizontal ellipse is going to be x squared over a squared plus y squared over b squared, which gives you, for this presentation I just put 1 based on the standard equation, but it can equal any number. Your vertical ellipse, the equation is x squared over b squared plus y squared over a squared equals any number. Now you'll notice that from horizontal to vertical, your denominators of x and y are flip-flopped. And the reason is because your major axis is always going to be a squared. Because a squared is always going to be your larger diameter. So, because x is your major axis, you want the larger diameter a underneath the x numerator. Same thing with your vertical ellipse. You have your x, but your x is b in this representation of the ellipse. meaning it's your shorter diameter, which is your minor axes B. So let's talk about major and minor axes. Okay, for the first example on the horizontal, your major axis A contains your verticals or vertices V, which is basically the 2 points of intersection of the ellipse on the major axis. Your co-vertices, which are represented this light green slash here, co-vertices, are always going to be on your minor axes, which is b squared within the equation. So, for example, your horizontal ellipse, major axes, vertices, minor axes, which is y, co-vertices. Now, let's look at the center. The center is a midpoint of the line joining the foci. Okay, we learned about foci in the previous slide. Foci, foci, center, center. Now, there is a relation. Your foci equation is a squared, which is your larger diameter. It's always your major. B squared, shorter diameter, always your minor. See the minus sign here? Equals C squared, which is your center, basically the midpoint of the line joining the foci. It's like the Pythagorean theorem, but you have a minus instead of addition within the foci equation. Now, I think we went over a little bit. I have 6 digital images that I just want to go over with you guys real quick, so you have a real-life representation of what an ellipse actually is. So, we're going to come to the computer here. Okay. So for this first example, I'm actually going to use my drawing tool, because on the next 5, the image is not as large. I'm not actually able to use the drawing tool. So if we look at this, this is called the ellipse flame, or flame of the ellipse. It's a beautiful piece of art here. So I have my drawing tool selected. So from what we learned in the presentation, this whole thing here is your ellipse. Okay? Now let's guess where your major axis is going to be. Well, we can see here, we see some vertices. Okay? Major axes. Whoops, sorry. Minor axes. Not that great at drawing a straight line, guys. Okay? These points here, it's the intersection. So that is your vertices. Obviously, you have your center here. Now your foci, the sum is a constant. Okay? Right here. And then right here on the minor axes, which is your y, will be your co-vertices. Alright guys, moving on to the next few pictures I have here. We look at this stage rock and roll concert here. We have your ellipse, okay, major axis, minor axis, center, foci on either side, and then the intersecting points are your vertices and your co-vertices. Next photo. Zoom in. Here's a tree in nature. Ellipse. Center. Foci. Intersecting points here and here. Vertices. Intersecting point there and there of the minor axes. Co-vertices. And we know because this will be with the foci on the same line, your major axes. Here is a drinking fountain ellipse. Major, minor, foci, foci, center, vertices, co-vertices on the y minor axis. My favorite, the NFL football ellipse, center, foci, foci, major, minor, vertices, co-vertices. And then our final one, which is the Gateway Arch of St. Louis. If we look at this, this is half an ellipse, but if you look down here in the water, the reflection here, it gives it the illusion the whole ellipse. So using your imagination, you can see where I'm going with this. This is actually going to be a major axis here on the y, which is different from the other ones. Minor axes here on x, center, foci, foci, vertices, vertices, always on the major, co-vertices, always on your minor. That does it, guys, for this webisode, so to speak, on Conic's Corner. I hope you guys can join me again. And until next time, Kelvin Conic signing off.